Hi class, my name is Isabella Rodriguez, and for the problem demonstration I decided to do chapter 12 number 17. So first I want to read you guys the question. Many know the feeling of being too groggy to take an 8 a.m. exam. We need to be more alert and aroused to do our best. Some of us also know the feeling of being too aroused by the prospect of an exam to do our best. Thus, the best level of performance occurs when we are in the Goldilocks zone, not too aroused and not too groggy. Simon and Moghadam recently replicated this observation in rats. Subjects were randomly assigned to one of three groups. Each group received a different dose, none, a medium dose, or a high dose of Ritalin, which is a stimulant. Researchers measured the rats' learning and cognitive performance and observed the highest level of performance in the group that received a medium dose of Ritalin. Suppose that the following data were obtained from a similar independent measures research study comparing three treatment conditions. So, though we know that this chapter is about ANOVAs, we have to be able to determine what we would use. So the reason that we are using ANOVAs in this for this question is because we are comparing more than two treatment conditions. That is why we need to use the ANOVA. Right here it states at the bottom that studying comparing three treatment conditions being no drug, medium dose, and high dose. So that's how we know that we're going to be doing the ANOVA. And this question is very wordy and it can get confusing, but all that we really need to know here is that we are looking for if there is an effect on performance from the amount of drug dose that someone is given. Does drug dose affect performance? So that's all really that we need to know from this. And also, of course, the chart is super important to note. For me, I decided to write everything out because that's just the way that I personally like to do things. I like to physically write out everything so it helps me to remember and, you know, all of the different equations. I'm a type of person who likes to number every single thing that I do within the equation. So, here, I wrote out the chart right here. And then the first part of the question asks asks us to use an ANOVA with a alpha 0.05 to determine whether there are any significant mean differences among the treatments. All that this is asking is basically, is there a significant effect on drug dosage and on performance? So we have to do the ANOVA and do all 4 steps in order to find that out. So the first step, we are going to state the hypothesis, which is, we should be familiar with this already, but you know, in every different hypothesis test, there is different formats and different things to note. So here we have state the hypothesis, step 1. Our HO would be mu1 equals mu2 equals mu3. That is our null hypothesis. All this is really stating is that all of the different conditions are equal and drug dose has no effect on performance. H1 is saying not HO. This is saying that there is a significant effect of dosage that the dosage of drugs has on performance. This is our alternative hypothesis. So then we would move on to step 2 and we would try to find the critical value. Also to note that this is the same type of steps that we've used in other hypothesis tests. Though here we have alpha 0.05, and we have to note that we have to find 2 separate degrees of freedoms here. We're working with between and within throughout this question. So the degrees of freedom between would be k minus 1, and here I've noted that k equals 3. K is just the amount of the conditions or treatment groups that are in the question, and here we know that there are 3. So right here we would do 3 minus 1 and we would get 2. for the degrees of freedom within, it is n minus k. N is capitalized here because it is the population n, and k is still the same as before. Here I've noted already that n equals 15 because of, why did I do that? Hold on. Oh, okay, no, because we're trying to find the amount. So we have 3 separate groups and we have 5 different scores in each. So 5 times 3 is 15. That's how we would get the population n. So 15 minus 3 is 12. So that's that. And then we would use the chart for the ANOVA. We would use the F distribution table ANOVA chart in order